In this lesson, we will solve rate and ratio problems using multiple representations. So we started this quarter first beginning with a jumping jack activity to determine our rate and unit rate. And then we defined ratios, rates, and unit rates and sort of sorted them in a graphic organizer. So let's start with the jumping jacks. We began by making a prediction. How many jumping jacks could you do in 1 minute? So let's say I'm thinking, I can do roughly 15 or so. So I'm gonna put 15 as my prediction. But then I actually did the jumping jacks and I realized I was able to do actually 25. So my rate, or in this situation, which we haven't defined it yet, a particular type of rate was 25 jumping jacks per 1 minute. Now I then use that to say, how can I now make a determination of how many jumping jacks I can do in 30 seconds? Many of you saw right away that 30 seconds is half of a minute, so I could do half that amount. So I would write that half of 25 is 12.5. And then to write that as a ratio of jumping jacks to time, I would say 25.5 jumping jacks, or JJ, to 30 seconds. Okay. And then I want to go to 2 minutes. And the reason why I want to go to 2 minutes is because I realized I could, the same way I halved my time, I could double the amount of jumping jacks. So in that if I double the time. So I'm just going to go down to 2 minutes and I'm going to multiply that 25 times 2. So now I have 50 jumping jacks. And what I liked particularly about this activity was that many of you found different ways to get this 1 1/2. Some of you use this number here, and I'm going to change that to, you can see it in red. You use this 12.5 jumping jacks in 30 seconds and said, well, if I can do that in 30 seconds, then I would multiply that by 3 because that would give me my 1 1/2 minutes, or 12.5 plus 12.5 plus 12.5. And either way, you got, just to be safe, I'm putting in my calculator. Yep, 37.5 jumping jacks. And we know that we couldn't actually get that 0.5, but we're using these numbers. And now another strategy I noticed was that you added the 1 minute, which was 25, plus the 1 minute, which was 25, plus the 30 seconds. So I'm going to erase this first one here. You added the 25 plus the 12.5, and either way you still got this 37.5. So that shows me that there's many different ways to figure out rate and ratio problems, or to answer any kind of math problem. Now this is what our interactive notebook should look like at this point. On one side we have the jumping jack activity glued down, and on the other side we have the Venn diagram, or graphic organizer, probably another word, that has the unit rates, and ratios. So let's look at this activity. So we were asked to sort the 60 miles in 3 hours, the apples to oranges, bananas to $1, desks to chairs, boys to girls 10 to 1, and let's move this up here, $2.99 per pound into these 3 categories. Now, one way I like to look at these categories is that the overarching theme, or the overarching family here, are ratios. So everything fits within this big family of a ratio. And then we get more detailed. We have more specific criteria to meet to be a rate. And then within the rate, there's even more details or criteria that we have to meet to become a unit rate. So let's first look at the ratio. Well, we define ratio, and we're going to define that in a second, as comparing two different types of things, two different types of quantities. So there's actually a saying, when you compare apples to oranges, that is a ratio, right? They're fruit, they belong to the same family, but there's no measurement, there's no real comparison there to be made, except in the numbers of quantities that they have. Another good ratio or a comparison that we noticed in our class was just boys to girls. So I'm going to add that in the ratio category. And you'll probably see that there's one that sort of sticks out that looks kind of similar to these. It doesn't have a number attached to it. And that would be desk to chairs. Now, we could have a desk to chair that was a ratio, 10 desks to 2 chairs, but it still would be a ratio because there is no measurement attached. Now we're looking at rates. Rates are when we have measurements. We have different units with measurements attached. So what can you measure? You can measure hours, you can measure miles, you can measure height. So 60 miles in 3 hours would make a rate. Right? That's a typical rate. A unit rate is when I have to compare it to 1. So 60 miles in 3 hours is a rate, but then if I did 20 miles in 1 hour, that now becomes a unit rate because my denominator is 1. So if I have bananas for per $1, I'm going to say that's a unit rate, sort of a loose, it fits loosely in unit rates, but I'm going to put it there. And then I'm going to put this $2.99 per 1 pound in there as well. Okay, because pound is the sort of the unit that I'm doing my comparison with. Now this one here, it has that 1, right? So you would think it would fit right here, but it's missing an important criteria. It's missing an important characteristic of a unit rate, and that is the units. I could be comparing 10 boys to 1 girl or 10 apples to 1 orange, and I don't know. So I'm going to just leave this here because it does not, as I'll see in 2 seconds. We need more information, right? It doesn't fit any of the criteria. We definitely know it is a ratio, but I can't place it anywhere else in this family because I don't know what I'm comparing. All right, so now take a moment. You could pause the video. These are the definitions that we wrote down in our notebook. Notice it's in the math vocabulary section, so that's the last 15 pages of your notebook. You have ratios, rates, and unit rates. So if you didn't bring your notebook home, that's fine. But if you want to watch this video another time to write these down, you can. So that's the end of this video. In the next video, we will be taking on that going on a hike and rates, ratio, unit rates, oh my.